In these questions, we're going to use Newton's law of gravitation to work out the answers. A short period of comet is 3 astronomical units from the Sun at perihelion and 36 astronomical units from the Sun at aphelion. So if we were going to draw it with the Sun here, this would be our comet at perihelion, 3, and over here at aphelion, 36. Well, how many times is the Sun's force of gravity on the comet greater when it's at perihelion compared to when it's at aphelion? Well, to work this out, we need to see how many times further away it is when it's at aphelion compared to perihelion. So doing 36 divided by 3 gives us 12. So it's going to be 12 times closer when it's at perihelion. But according to Newton's laws of gravitation, the strength of gravity would be proportional to the square of that. So 12 squared would be 144. So it would be 144 times greater when it's at perihelion compared with at aphelion. A satellite is in a very eccentric orbit around the Earth. It is 11 times further away from the Earth when it's at apogee compared to when it's at perigee. Calculate how many times stronger the Earth's force of gravity on the satellite is when it's at perigee compared with at apogee. So similar to the last one, it will be proportional to the square of how many times further away it is. So 11 squared means it will be 121 times stronger at perigee compared to apogee. An asteroid orbits the Sun in an eccentric orbit in which the aphelion distance is 3.5 times greater than the perihelion distance. By how many times weaker is the Sun's pull of gravity on the asteroid? So again, the same thing we do, which is 3.5 squared, which is 12.25 times weaker. When a long period of comet is 40 astronomical units from the Sun, the pull on the gravity on the comet by the Sun is F. How far is the comet from the Sun when the Sun's pull of gravity is F divided by 16? So for doing this, we need to work out the square root of 16, which equals 4. When it's going to be weaker, it'll be 4 times, therefore, further away. So 40 astronomical units times 4 is 160. So the answer is 160. It'll be 160 astronomical units away for the force of gravity to be 16 times weaker. Fragments of a comet are on a collision course with the massive planet Jupiter. When a particular fragment is 0.075 astronomical units away, Jupiter's pull of gravity is 100 units. How many units is Jupiter's pull of gravity on the fragment when it is only 0.015 astronomical units away? Well, we know it's going to be larger because it's closer to Jupiter. So firstly, we need to find out about how many times closer it is. So to do that, we'll do 0.075 divided by 0.015, which equals 5. We know that it's going to be 5 times closer, so the pull of gravity will be proportional to the square of 5, which is 25. So it's going to be 25 times larger. So if it was 100 units, 25 times 100 to give us the exact pull of gravity means it would be 2,500 units. Mercury orbits the Sun at a distance of 0.39 astronomical units. So there's Mercury, there's the Sun, so it orbits at a distance of 0.39 astronomical units. By how many times is the Earth's gravitational pull on Mercury greater when Mercury is at inferior conjunction than when it is at superior conjunction? So we've got 2 locations for Mercury. So this would be superior conjunction, and over here would be inferior conjunction. So we can firstly work out the distance between Earth and Mercury at inferior conjunction. So this distance here would be 1. 1 minus 0.39 gives us 0.61 astronomical units. And at superior conjunction, we can work that out. So the distance here would be 0.39. Add the 1 astronomical unit, so that would be 1.39, when it's at superior conjunction. We then want to find out how many times closer it is at inferior conjunction. So we'll do 1.39 divided by 0.61, which gives us 2.278 continued. And then to work out how many times greater it would be, we need to square that number. So 2.278 squared gives us 5.19. So the pull of gravity would be 5.19 times greater when it is at inferior conjunction rather than at superior conjunction.